Okay, so I was saying, whenever we're looking at stoichiometry, these three things are very important. As we talk about the percentage yield calculations, we look at determining what is limiting, what was in excess, how much was produced. Even as we look at titration, titration is more involved in trying to determine the concentration of the reactant, where we've given you certain information about the other. Even as we talk about back titration, redox titration, they are all dependent on these three things. So now, I was saying, all these things are formally defined in the videos that you're going to be accessing on Moodle. Now, the area of interest, or what will allow you to be well in chemistry, of course, even as we proceed on, it is very important you understand stoichiometry. That's why I always repeat these whenever I'm teaching this topic. So, when we talk about a mole, do we understand at this level now how we basically get to determine a mole of a given substance? How do you determine the mole of a substance? Anyone to help us? I believe I'm asking this because I believe you've learned certain things already in class. So if we can get to interact, that is going to be even much better. And then I'll add on where you've left out.
Mass equal mass over volume. Mass over molar mass.
Okay, so mass over molar mass. Anyone with another answer? Anyone with another answer? Nobody? So we all just have one answer. Okay. Why is the network so against? Are you getting me?
Yes, we get you, sir.
Yes.
Okay, so the other formula is what? That's what I want to hear. If you looked at that formula already, I just wanted to hear that. Number of moles is equal to concentration multiplied by volume. You haven't. But you're talking about titration. You can't do titration without talking about that. Anyway, um, I'll still explain now in detail. Let me just try just to explain.
Yes.
You've looked at it, right? Is that an agreement to the question?
Yes, it is.
So when you're talking about solids, for example, we understand that if I give you a solid, there are two things that you're able to do. You're able to measure the volume of this solid, right? You're also able to measure what? More important, you're able to measure its mass. Now, the molar mass is going to be dependent on what? The element that it is. So if you look at the periodic table will be able to give you the molar mass of that solid that you have. So you can consider, for example, if you have sodium, right? Sodium is a metal. So you're able to weigh your sodium to get the mass, and then you're also able to get the molar mass from the periodic table because the periodic table tells us what the molar mass is. So in this case, this is what we are saying now. The number of moles is dependent on the mass over molar mass. I'm not a fan of memorizing all these formulas because I like understanding the units. That way it becomes easier. So we understand that the number of moles, the units are moles, and then the mass, the units are grams. Molar mass, we say grams per mole. So this should add up. Okay, so that's the way it works. So what am I trying to say? What I'm trying to say is, if you've forgotten the formula, if you've forgotten the formula of the mole, what you do is do this. If you look at the molar mass, the units of the molar mass is grams per mole. You write that. And then if you talk about the mass, the units, preferred units when you're dealing with mole calculations, we use grams. So ask yourself, how can I arrange these? Because I understand that my moles, the answer is supposed to be a mole. Now, which part are we seeing a mole? We are seeing a mole in the molar mass. Now, we are seeing it on the bottom. So for us to have it on top, it's like we're supposed to divide. So it's like if you have 23 grams per mole as your molar mass, and then you have a mass of, let's say, 20 grams. How do you find the number of moles? So, respectively speaking, what we're going to do is, where you have a mole, the mole go on top, and then you have the 23 grams on the bottom. But you still maintain multiplying by the 20 grams. So that is a deliberate movement so that you can cancel out the mass and then remain with the unit what? Moles. So if you try to assess this, the other way you can look at this is it's like you're just dividing this value into that value, which now gives birth to the formula that we see, which is now this being the mass, and then you're dividing by the molar mass. And of course, the units do show up to be correct. Is that simple for everyone to understand? Have I lost anyone? So there's a hand, you are free to ask your question.
Can you repeat what you said?
I've said a lot of things. What am I going to repeat?
Starting from the formula.
Okay, if you're able to remember the formula, it's well and good. That's fine for me. Are you able to remember the formula? I was just trying to make sense to in case somebody is struggling to remember the formula and the like. Are you able to remember the formula?
Yes.
Thank you. So, I believe we've also talked about concentration now. Concentration is how do we define concentration? Before I talk about the way we calculate them more, another way. So now, of course, the reason why I'm talking about concentration is we need to think of now solutions. We don't only deal with solids in chemistry or powder, things like powder, blocks, those things. We don't just deal with that. We can also deal with, you know, liquids now. Actually, we deal with liquids more. Actually, I need to use the term solutions. We deal with solutions more. Okay? So now, how do we get to determine the concentrations, the moles of these solutions? Of course, before that, what do we understand by the term concentration in respect to a solution? Okay, the amount of solid dissolved in a solvent. Yeah, that's fine. Solvent can be water, and then a solid can be something like sodium carbonate. Oh, yeah, any solid you can think of in chemistry. Sodium chloride, for example, which is a common salt, table salt. That is an example of a solution. So now what we're trying to say is trying to define it more that you're going to understand it chemically. I would say the concentration is the number of moles dissolved in a volume of the number of molecules dissolved in the volume of a solvent, or it may be the moles per volume of a solvent. That's still a simpler definition of the concentration. So in other terms, what we're trying to say is, of course, maybe before I even try to make another statement, molarity is a unity of concentration. I look at it to be a unit of concentration, but of course it is a concentration. So molarity is a specific kind of a concentration where it is moles dissolved in what? You go direct in a liter of a solution. Now a liter can be decimeter cubed, because the liter is equal to a decimeter cubed. So if you have a number of moles divided by the volume in liters, it gives you what we are calling molarity. Now I'm saying molarity is a concentration, except it has got specific units. Concentration is general. What am I trying to say? What I'm trying to say is this. For concentration, you may have the number of moles of that solution, of that solute that you put there, per, let's say the volume was measured in cubic centimeters. That is also a unit of that concentration. Now, molarity is very specific. It's just always going to be moles per what? Per liter. Now, I'm saying a liter is equal to the decimeter cube, which basically means we can also have moles per what? Per decimeter cubed. Now, for concentration, all these also apply to concentration. Okay? I'm not saying, I don't want you to get to a point where you say now, no, concentration is different from molarity. No, molarity is a certain type of a concentration with specific units. Now, I'm trying to say concentration can have different units. We may even have moles. I know you've learned different ways of measuring the volume, right? How else do you measure volume? Even just meter cubed as well is also a volume measurement. In fact, concentration can be in grams per liter. Like if you look at things like density ovals, like concentration can be, as we'll see later on, things like parts per million. All those are ways of measuring concentration. But more specifically, molarity is very specific. If you're able to remember the units, you're able to come up with a simple definition of molarity, which is going to be very useful because now what I've highlighted there can be denoted using a capital letter M. So if you see 2 molar concentration, it means that capital M is the same as moles per liter. So that will allow you to perform calculations easier and faster. Now, I've talked a lot now. Let me give you an example. Determine molarity of 32 grams of sodium dissolved 32 grams of sodium chloride dissolved in what? We can say 9,000 nanometers. Hey, am I trying to say? I'm supposed to see this volume there now. So what volume can you think of? Say volume, it can be okay, better of 90 milliliters. Is milliliters a volume of water? Okay, thank you. So milliliters is a volume. We have the mass of sodium chloride. How simply can we determine the molarity of that? So simple and straightforward, ladies and gentlemen. What we're going to do is, I've already explained now what molarity is. Now you don't need to stress yourself. We understand what molarity is. We've said moles per what? Moles per liter. I'm trying to train you and prepare you. And of course, I'll still remind you to share the link with your friends so that your friends can also understand what you're getting here. So if we've got moles, that's what I've said. I've said molarity is what? I said molarity is moles per liter. We understand that fact. Now, even when you don't know the formula, you'll still be able to answer if you know that fact, to say molarity is moles per liter. That means that I just need to find the number of moles and then I'll divide by what? Liters. Now, how do I find the number of moles? That's the question. So now I understand that I've been given 32 grams, which is a mass. Now I already showed you how we find the number of moles, and some of you still have mastered the formula. So number of moles is mass divided by the molar mass. So in this case, we've been given sodium chloride. So if you look at sodium chloride, it is a mixture of sodium and the chloride there, which is chlorine, of course. So if you look at the periodic table, kindly help me with the molar masses of the two. What's the molar mass of? I believe sodium should be 23, approximately. Of course, the periodic tables they give you now have got decimal numbers, but we'll still ignore that for now. Chloride should be what? Yeah, chlorine. 35.5? Is it 36? Anyone with a periodic table to help us, sir? Nobody.
35.
35. Okay, thank you. So if we add the 235 plus 23, I believe we should have 58, right? Approximately. Now the units of molar mass is what? 58 grams per mole. So if even if you don't know how to find the number of moles, ladies and gentlemen, you can still understand. You've got 58 grams per mole. Now you want to find the moles, so obviously you need all the mole on top. So I'll take the mole on top, so that we have more over 58 grams. Now we've been given the mass of this solute. The mass is 32, so we need to multiply so that the grams can cancel out. So in other terms, some of you know the formula and don't want to do what I'm doing, which is shows that you're understanding chemistry. If you're able to see what I'm doing, you can still remember the formula. Number of moles is equal to mass over molar mass, which is 32 divided by the molar mass we've calculated to be 58 grams per mole. You still get the same answer. 32 divided by 58 is what we are basically doing to find our number of moles. So we've now found the number of moles, I believe. Somebody who has divided 32 by 58. What are we getting? 0.5517.
5517.
So what is moles? A mole. Okay. Now a liter. We don't know what a liter. So a liter, we've been given the volume of water to be 90 milliliters. Now, some of you were there initially, and some of you have been watching my videos. I did talk about what a milli stands for. A milli is the same as dividing by 1,000, which is the same as multiplying by 10 to the power negative 3. Now liters stands out. Any question about that?
I'm sorry, I was disturbed by a call, so I didn't get the definition of morality.
Oh, molarity is how we just said moles per liter. As simple as that is. Number of moles dissolved in a liter of a solution. Is that okay?
All right. So the SI unit for morality is gram per mole.
What are you saying? Molarity has got an SI unit. I didn't know what. I believe that applies to the. Oh, anyway, it is a derived. I don't. You're confusing the teacher. The units of molarity, if that's what you're asking, it's moles per liter, which is the same as having
Oh,
a capital
sorry.
letter M.
Yeah, sorry. The units. Yeah, yeah. That is what I wanted to ask.
Thank you. Any other question? And somebody should just punch that for us so that we have the answer as in molar concentration.
Sir,
Yes, ma'am.
I don't understand why you said milliliters and how we're getting the 90 times 10 to the power negative 3. So if you could please repeat.
What do you understand by milli? I want you to tell me what you understand, not what you are saying, what you've seen here.
I don't understand, so I'm asking, sir.
Supposed
Um,
to have a table of units for it.
but you're not always going to have it. It's not given in the assessments. You need to know it.
No, as in you're supposed to know. As in you're supposed to know the table.
Yes, yes. Yeah, that's you're supposed to know it. So milli is a smaller unit. We use it when you're trying to express something small. Okay. I believe you understand. We all know what a 5 liter is, right? We all know what a 5 liter container is. Now think of a case where you have a cup, right? maybe okay, you know what a 2 liter is, the just bottle. You also know what it is, not so. I'm trying to make you understand this. You know what it is, right? And then
Yes, sir.
we can now go to a cup. You know what? You look at a cup now. You know that just bottle is a 2 liter. Okay. Now imagine you have got a liquid. Now you've got water of the same just in your cup. Now you don't want to use the smaller unit. You just want to use liters. You understand? Okay? So you may end up having something like 0.00 something liters. Do you get that? Because it is smaller compared to bigger containers. Okay? Are we together? Are we together? You've got a 2
Yep.
liters of just. Now, if you put it in water, it may be something like 0.0 something liters, which means it is small. Now, you don't want to complicate things as like that. What you basically get to do is instead, each time you have a value of, let's say, 0.001, you consider it, instead of saying 0.001 liters, you can now say, okay, I'll just call this to be 1 milliliter. You understand, ka? So which tells us that this small letter m is representing 1, 2, 3. What does that mean? So if you've moved the decimal from this side, we understand that it's a negative. Some of you understand that mathematically. So it's the same as 1 times 10 to the power negative 3 in liters. Now, the other way is, some of you are not who don't understand mathematics. If you look at 1 milliliters, to take it back to the original measure, you can just divide by 1,000. It will take you back the same answer. So now dividing by 1,000 is just the same as multiplying by 10 to the power negative 3. Are we together?
We are together, sir.
I'm trying to make you. I'm trying to be as slow as possible. Just okay. Thank you. What you understand? And has anyone now the lady that asked the question? Have you now gotten why we were multiplying by 10 to the power negative 3? Because we are interested in finding liters.
I have.
All right. So anyone who has divided, so that we have our answer in molar concentration.
6.13 moles per liter.
6 point.
13 moles per liter.
Moles per liter. So instead of saying all that, you can just say capital letter M. That is molar concentration. Are we together? Guys, chemistry is very interesting. You just have to.
Yes.
So now, for the students that are going to continue learning with in my classes, I don't want you to be like, I don't want you to rush. I don't want you to rush. That's the mistake that most of the people make. Um, this topic that there is a reason why you start with stoichiometry, by the way. Like, as you get to look at electrochemistry, thermochemistry, kinetics, these things are going to be dependent on these issues that I'm talking about right now. That's why I'm trying to take my time to just explain them. So I said there are 3 things that I want you to understand as we build our understanding of stoichiometry. I said, who is about to remember what I said? There were 3 things I mentioned: moles, mo. What else?
Um, more ratio,
The more ratio and limiting reagent.
limiting reagent.
So now, for your own information, these are dependent on one another. So you can't understand what mole ratios are if you don't understand what a mole is, and then you can't understand what a limiting reagent is if you don't know these two, moles and mole ratios. Okay, so I believe we now know how to determine the moles. I've talked about both solutions stoichiometry, which deals with concentrations, and then I believe the other one is simple, the issue of The issue of what? The issue of the masses. We say this as mass over molar mass, right? When you have got solids, that's how you find the mole. So we understand that idea. Now, tonight I'll end on more ratios. I'll just give you an example. I like giving this example every time. You've got 2A plus B, giving you 3C. I'll give you an homework from here, just here. So if you look at this, consider a case where molar masses are as follows. The molar mass of A is 20 grams per mole. Anyway, we understand that the molar mass is units grams per mole, so I'll just write the values. For A, 20, 40, 30 for C. Those are the molar masses. And then the other thing that I want us to put into consideration, now let's assume we had what? We had 2 grams and 2 grams. Maybe the ribator, I may even put a 4 there. Now, let's assume we had 2 grams of A and B reacting together to give us C. So the way this works is this. Maybe I can remove the 2 grams first of all. So assume that in this case we know that the mass of A is 2 grams, and then we know that the mass, its molar mass, is 20 grams per mole. Is that information clear enough? So in the actual sense, in the question, the way it's going to be is they'll give you, for example, oxygen. So you understand on the periodic table you'll be able to get the molar mass, right? And then they can give you the mass in the question. Now, of course, I'm using this example. Of course, later on we'll look at solution stoichiometry where they can give you, instead of mass, they tell you the volume. You understand? Even concentrations, all that. We'll look at that as well. Don't worry. So now, using more ratios, you should be able to determine how much of the other reactant is required. How? So if you look at this number that is here 4, the 4 you are seeing there, it is not just there for decorations. What it simply means, by the way, we call these more ratios. In other terms, I can just call them stoichiometric coefficients. Okay? That's why it is very important for you to balance a chemical equation. So what am I trying to say? What I'm trying to say is this. When you are baking, I hope we've baked before. When you are baking, if you're adding sugar to whatever you're baking, does it mean that if you add 10 spoons of sugar, you're also going to add 10 spoons of salt? Is it true?
No.
How many spoons of sugar, of salt should you add? Less, not some. Let's say for argument's sake, we'll say 2 spoons of salt. The concept I'm trying to bring here is there's an aspect of ratios here, right? So it's like per every 5 spoons of sugar you have, you're supposed to have a single spoon of salt. I've just divided by 2 both sides. So it's like 5 spoons of sugar will need a single spoon of salt. Are we together? Are we together there?
Yeah, follow. Yes.
That's what it means as well when we say 4 to 1. It means per 4 moles of A available, there should only be a single mole of B required to react. Are we together? Are we getting that idea there? So it doesn't necessarily mean that if you've got A and B reacting in the reaction, then they should all be of the same masses. Even if they're of the same masses, one of them is going to be more than enough, because the ratios tell us in this case that it is in the ratio of 4 to 1. So considering a case where you have 4 to 1 as our ratio, and then you've got 2 grams of air, you should be able to determine how much of B is required to react. How? we'll find the number of moles. We said number of moles is molar mass divided into what? The mass. So 2 grams multiplied by mole, which is like just dividing by 20 grams per mole. What answer are we getting there?
0.2.
Moles. So we have 0.2 moles of what?
0.1. 0.1, sorry.
0.1 moles of what? Of A. Are we together? We found the number of moles of A. So for us to find how much of B will be required, what do we do? Now this is now what I'm calling mole ratios. So these guys are in the ratio of 4 to what? To 1. So if you have got a 0.1 mole of A, how much of B are you going to have? You're now using ratios. You put a variable there to represent that. So if you cross and multiply, you have a 4x equal to 0.1. Divide by 4 both sides, what do you basically get to have?
0.025.
So your answer now becomes 0.025. So those are the number of moles of what? Of B that will be required to react with the 2 grams that we add of what? Of A. Now I've used mole ratios. Now the mole ratios, what we've seen here is I'm using the mole ratios to compare the moles. Okay? So if I can find the moles of A, I can use now, what I'm trying to say is if I can find the moles of A, I can use the mole ratios to find the moles of B and also the expected moles of C to be produced. But of course now that becomes to be dependent on the limiting reagent, not just mole ratios. So now for me to find the mass, I've found the number of moles of B required. I'll use its molar mass, 40 grams per mole, and the moles to find the mass. That is easy for us, not so? So we understand that.
Didn't hear a thing.
We understand that. Anyway, you watch a recorded class if you didn't get anything. Don't worry, the class has been recorded. Okay? So basically, that is a basic idea of the mole ratios. If you're able to find the moles of one, you can use it to find the moles of the other using the mole ratios. And then, in this case, after finding the moles, we're able to find the mass of B by using its molar mass and the number of moles. Now, your homework for tonight is this. I want you to find the limiting reagent. In a case where we have 3 grams of A and 6 grams of B, I want you to find which one is going to finish faster in the reaction between A and B. Are we together?
We are together, sir.
Yes. I want you to find the one that is going to finish faster in the reaction. And that is the first question. And then the second question is determine how much of C will be produced at the end of the reaction. So determine limiting reagent, determine amount of what? C produced. Blessed night, everyone. Thank you for attending the class. Share the link of the recorded class with your friends as well if you enjoyed the class. Thank you for attending. Good night.